In this video, we will cover the main logic of our Leatherback project, in which we teach a four-wheeled robot how to navigate through waypoints in Lab. This video is the follow-up of part 2.1 that is being covered on the platform LycheeAI.notion.z, where you can find previous tutorials along with the videos. You will find the link in the description below. Now in part 2, we have already covered the part 2.1, where we went over the train and play scripts and the Leatherback configuration, in which we specified the Leatherback USD file and the configurations, for example, the four wheels and the knuckles. And in part 2.2, we're coming to the main part, which is the most important step. We will start by registering the environment. This will link the environment to the configuration files and set up the RL PPO configuration. Then we will have a look at the PPO algorithm and its network architecture and training hyperparameters. And finally, we have two scripts which define the main environment logic. This is the heart of the project, as it controls the whole environment with a direct workflow and allows us to connect the Lab simulation with the neural network's inputs and outputs, along with a small separate waypoint file for the navigation part. The last one is just the USD file, so basically the 3D model. And because many of you have requested this, I will dedicate a whole video on this in Sim, which I will call part 0, as this will be then the beginning. Okay, so right now I have put the guide on the side so we can also have a look at VS Code. So first of all, we stored the files under source, Lab tasks, again Lab tasks, and direct, and then we can find it on the Leatherback. This follows the Lab convention. So we will start with the initialization file, which registers the gymnasium environment in order to link the PPO algorithm to our environment. As we have already covered how to register the environment in a previous video, I highly recommend watching this. You can find it on the platform or also on my YouTube channel. But yeah, let's have a quick look at it. So in here we set the ID, which we can choose. In our case, it's Leatherback Direct V0. Then we have the entry point and also the environment configuration entry point. These are pointing to the script that we will talk in a moment. And in here we also have the two classes which are inheriting from the direct workflow. And at last, we also have an entry point to our reinforcement learning algorithm, which we will cover now. So we are coming to the agents PPO algorithm, which is a very popular reinforcement learning algorithm, which is made possible by the RL library. We can find it under agents and the RL PPO configuration YAML file. I'm currently working on an explanation video of how this algorithm works within Lab. You can also find it on the platform here, but for now, we're just summarizing the most important configurations and hyperparameters. And if you want to have a deeper understanding, you should check out the RL documentation, which is also linked here. So as a little disclaimer, I will simplify a lot. So the PPO algorithm consists of two neural networks. One is the policy network, which is also called the actor. It is basically the decision maker. And here we have 8 inputs, which are the observations. In our case, these are the informations, for example, the robot's position and velocity. And we have 2 hidden layers with 32 neurons. And the outputs are our actions, which are 2 driving instructions. In our case, the throttle speed and steering wheel angle. Then we also have a value network, which is also called the critic. It is basically evaluating the situation. It has the same inputs, but the output is just one single number that is basically estimating the value. All the information together are used to evaluate and update the neural network in order for it to train. Inside the YAML file, we can then specify the model parameters. For example, for the policy, we set the inputs as states, which we will define later as the observation, the 2 hidden layers, and then the outputs, which are the actions. Also for the value network, we see the same inputs and the output is just one value. Okay, so now coming to the memory setup. So basically the memory is storing experiences of a complete rollout, which is then storing individual transitions like state, action, reward, next state, or return flag. So basically a rollout is the process of running the agent in an environment to collect the data. This is in most cases the complete simulation from start until termination. In some contexts, it's also called an episode. So inside the YAML file, we can see the memory parameters here. Now we also have some basic settings like the rollout size, basically how many physics steps are taken for each rollout, the epoch size and the mini batch size. These we can, for example, find here. Then we have also PPO specific parameters like learning rate or clipping. And finally, we have some training configurations. For example, how many training steps we want to have. In our case, we defined 9,600. And then we can also decide where and how we want to log the experiment data. The next part is probably the most important, as it is the heart of the whole project. In here we will go over the direct workflow implementation, which allows us to define the Markov decision processes and connect the Lab environment with the neural network in order for it to train. I will cover it in the next part of this series. And make sure to subscribe to not miss any videos.